Thank you. Thank you for coming. Like you could heard, my name is Balazs Bucsay, and I'm going to talk about this XFLTReaT stuff that I'm working on for a long time. But first, I would like to say thank you for voting for this talk, and thanks for the organizers as well for this beautiful conference. And I'm really happy to be here in Singapore. This is my first time, and I'm really enjoying it. So thank you. So let's talk XFLTReaT in a bit, but first a few words about me. So I'm a Hungarian hacker, but I live in the UK right now. I work for NCC Group. I just got promoted 2 months ago to senior security consultant, and I have some offensive security background. I started to do low-level ICT stuff when I was 13 years old in 2000. I was playing around with Ringo debuggers and disassemblers. Then I had a few major projects in the past. In 2009, I created G.I. John, which was a patch for John the Ripper. It made it distributive. Then 2 years ago, in 2015, I did research on HTTPS. I created a tool which is open sourced. You can find it on GitHub. If you want to learn about HTTPS, or you just want to use a tool to break out HTTPS environments, that's a really good starting point. And now this year, actually last year at Christmas, I started to do my new research project, sorry, which is the XFLTReaT, and I'm going to talk about this one right now. You can find my Twitter handler as well on the slide, which is X or EIP. Please follow me if you like the presentation or the tool. And there is my LinkedIn profile as well. I had some presentations around the globe, in the US, all around Europe, in Russia, UK, Hungary, Austria, Norway, and now I'm here. Thanks again. And let's start. So if I need to summarize my topic, this talk in one word, I would say tunnels. So let's start with a question. Do you know what are tunnels? Please raise your hands if you do. That's good. Have you ever used Cisco AnyConnect VPN? Please raise your hands again. Yeah, more and more people. Maybe OpenVPN? Raise your hands again. Yeah, more people. So you know what are tunnels. But for those who don't know what are tunnels, let's see this figure. On the left-hand side, you have your computer, which is connected to a modem or router that is connected to the internet, right? And you have two servers on the right-hand side. One is a VPN endpoint, a tunnel endpoint, and the other one is a server with cat videos, full of cat videos, because you like cat videos, so you want to watch those. If you want to download your videos from the server, for example, over FTP, you need to connect to the server over TCP, send some packets, you will receive some packets from the server. That's all going on TCP, as we know. All the routers, the internal hops, will see your packets. They will know what are the content of the packets, what is the original destination, and what's your IP address. They can inspect these packets if they are not encrypted, and they will know what you are watching. But if you use a VPN solution which is encrypted, then you will have an additional layer of security. All of your packets will be encrypted. The internal hops between you and the VPN server will only see the encrypted packets, and all of the packets are going to the VPN server. So they won't really know what are you browsing on the internet that way. And then your tunnel endpoint, your VPN server, will forward your original packets to the original server. So the other server, this one, will only see that won't see your original IP address. It will only see the VPN server's address. So why would you use VPN solutions in real life? Because, for example, you want to work remotely and you need to access your company's internal resources like file shares, emails, that kind of stuff. So you just connect to the corporate VPN server. You get an internal IP address and you can access your data in the company remotely. Or if you want to hide your real IP address because you are doing BitTorrenting, or you are a whistleblower, you just want to report stuff anonymously like journalists do, or some people do that, then you can use VPNs. That's some kind of solution. I personally use VPNs for different reasons. For example, my ISP filtered different ports like SMTP and NetBIOS ports. So I use my VPN server to get unfiltered internet access and then connect to my SMTP server. But with tunneling, usually you can bypass corporate proxy policies or just get the portals on airports and that kind of stuff. Probably there are more reasons why you could use VPNs for, but that's about the summary. So I have some more questions for you. Have you ever done any tunneling which used TCP as a transport protocol? Few of them already did. So please raise your hands if you've done, and could you give me an example? Some of you? Yeah, that's great. Thank you. So for example, OpenVPN or Cisco AnyConnect using TCP. Can you give me an example for UDP maybe? OpenVPN, yeah, thank you. That was great. Have you ever done ICMP tunneling? Raise your hands, please. Yeah, can you give me a tool maybe that you used? Yeah, but have you used a tool for that? Okay, let me give you a few examples. It's not the full list, of course. You can use different tools like HANS, Ping Tunnel, ICMP ticks, and there is more. What about DNS? DNS tunneling, have you done any DNS tunneling? Raise your hand, yeah? Maybe a tool? Yeah, that's really famous, Iodine, but there are more. If you have a proxy and you make a connection over that, you can proxy your stuff, you can tunnel your stuff. You can use Proxyfire, or OpenVPN has support for that. But what if there is no support on that firewall and you want to get unfiltered internet access, you want to do tunneling? I didn't really find any tool for that. Probably there are, but it's hard to find. What if you have a proxy which supports, which allows you to do connections over TLS version 1.2 only? I don't think there is a tool that you can use for that, or I didn't find, but I'm more than sure if it's TLS version 1.2 with, for example, Kerberos authentication, then you are screwed. You can't really do anything at the moment. You have to write your own tool. So in the same time, I really like to travel, so I'm pretty happy to be here because it's a beautiful place. And I will spend some additional days here in Malaysia, so I'm pretty happy about that. But in the same time, I mean, in the past, I went to Africa, last January. Actually, I went to Morocco from Italy, and I took the ferry. It was a ferry. It wasn't like a cruise like this. And I had a really small cabin with no windows, so I was bored. There was Wi-Fi in the room, in the cabin. So I started to poke around. I figured out that to get unfiltered internet access, you have to pay like really expensive money, which I don't tend to do if I can do other stuff. So I started to poke around and I realized that the HTTPS port 443 was unfiltered. So if I have set up an OpenVPN server on that port before I leave, I could have unfiltered internet access for 2 days and I don't get bored, which I didn't do. The next time I had a flight to Japan from Hungary, which is about 10 hours. They had Wi-Fi on the airplane again. I started to poke around and I realized there is ICMP, which is unfiltered. So if I have set up an ICMP tunnel on my server before I take the flight, I could get unfiltered internet access again, but I haven't done that. And this is coming back to me every time when I go to an airport. DNS tunneling is working like almost everywhere. And I was pretty happy because I set up my DNS server, the DNS tunneling solution. But when I connected it, it didn't work. Probably it crashed, so I was unhappy again. And this is when I started to think about that I should do something about this, because tunneling, like a topic, is really old and nobody does anything with that except using the tools nowadays. So maybe there is space to improve. So I started to write a list like this that what kind of problems do I have with these tools? So you need to install different tools for every different protocol that you want to use. The configuration files are different. You need to learn the syntax. You need to learn the arguments. You need to configure everything differently. The languages are usually different. Some of them are Python, some of them are Perl, and that kind of stuff. So even if you have an issue, nobody cares because most of the tools are end of life or unsupported now. So you can either fix your own bugs in the tool on different languages, or you write your own sometimes. And there is no automation at all in these. So in total, in general, it's really hard to do tunneling nowadays, but it doesn't have to be hard. So this is why I started to write my own tool, which is a framework. This is XFLTReaT or XFLTReaT, depends on how you like to pronounce. So this is when I started to work on that. But before I start with the stuff that matters, let me give you a lecture about tunneling. So this is tunneling 101. On the right-hand side, we have the Matryoshka dolls. These are really famous Russian dolls. And with that, you can place each and every doll into another one, and at the end, you will have only one. That's the point of that. So tunneling works like the same. It is the same actually, that you have a tunnel that can be placed into another tunnel, which can be placed in a third tunnel, that can be placed in a fourth tunnel, and so on, which makes completely no sense after a while. But if you do it one or twice, that makes perfect sense. So for example, if you have a network which has everything filtered but ICMP, then what you can do, you can set up your ICMP tunnel client and server, client on the network and the server outside of the network, and you can start to package all your packets into ICMP. So for example, we have a TCP packet because you want to download your cat videos over FTP. So you want to connect to that server over FTP, which is TCP actually. So you have all these packets which are sent to the interface, and the tunneling solution will care about will care of the packets, so it will encapsulate all the packets into ICMP packets. Because of the ICMP is unfiltered on the network, it can be sent to the server. The server will encapsulate the packet, and you will get the same original TCP packet what you sent originally. And that will be forwarded to the original server. So that's how VPNs and tunnel work. And when the server answers, then you will have the same packet on the other side, and the same thing will happen in reverse order. So what's XFLTReaT actually? It's not just a tool, it's a framework. It does lots of things. It's open source, it's Python-based, object-oriented, modular, multi-client, plug-and-play, and so on. Let me give you a few examples. For example, after the presentation, I will release the tool, so you can download it. If you want to install, you just need to clone the Git repository, which will be on the slides. You need to install the requirements with only one command, and there is only one dependency right now. After that, you edit the configuration, which is, I guess, pretty straightforward, and you run it. All the transportation module, all the transportation protocol stuff, the tunnels actually, and the encryption, authentication are and will be modular. It's plug and play, so if there is a new module introduced by me or somebody else, you just copy those files into the right directories, and you edit the configuration again just to enable those modules, and you are good to go. So, like I mentioned, it's not just a tool, it's a framework. So, when you want to create a new tunneling solution, you have to do lots of other things, not just tunneling. Because like I showed you, oops, what did I do? Like I showed you here, this is really tunneling. So you need to know how to send packets and how to receive. That's tunneling itself. But in real life, you need to do, like, you need to set up your interface, you need to set the IP address, the routing table. If you want to handle multiple clients, you need to do that as well. If you want the packets to be encrypted, then you write your own encryption, which is not the best solution, but you can do that, or use just different libraries, but still you need to care about those. But with this framework, you don't have to care about these at all. You only need to write your own module, which knows how to create packets on that language, on that protocol that you are using. And you need to know how to encapsulate those packets into, I mean the original packets, into your transportation protocol. So you need to just implement those things, and the protocol specific things, and you can work with your own tunneling module. So I think the check functionality is one of the best feature, the coolest feature of the framework. When you are on a network which you don't know anything about, and you want to do tunneling, then in the past you started to do Nmap, mapping the network with Nmap, for example, using SCAPI and that kind of stuff. But with the check functionality, if you configure the tool properly, you can just write -- check, that's the argument, and it will send challenges to the server over every module, every transportation protocol, for example, TCP, UDP, ICMP. And if there is an answer from the server, then we will know two things. First of all, that there is an XFLTReaT server because it answered to the challenge with the proper result. And that transportation protocol, for example, ICMP, is working. So probably you can build up a tunnel on that. This is the server side of the tunneling solution of the framework. We have the internet here. The clients are connecting from this direction to the XFLTReaT server. The purple boxes are the modules. In this picture, we have several TCP modules because we have different clients, UDP and ICMP. If the client is using ICMP, then it will send all the ICMP packets there through this line. The module will care about the decapsulating. That will be, the original packets will be forwarded to the tunnel interface. The tunnel interface handles everything about readdressing the packets, and that will be forwarded to the kernel. And the kernel will decide what to do with those packets. Usually, it just forwards it to the original destination where you wanted to send the packet originally. When there is an answer, it comes back, actually it arrives to the network interface, to the network card of your computer. It will be handled by the kernel. If the kernel thinks it should be forwarded to the tunnel interface, it will forward to the tunnel interface. And this is the thing. When you do tunneling, you usually have one user on one interface. But in this case, in this framework, I have only one interface for all modules and for all users. So at this point, I need to select which module should be sent to that packet, which module should it send to, sorry. And how I do that, I just check the IP address, the internal IP address of the packet. And if it matches to a client, I know where to send it. So I send it, for example, to the ICMP module that encapsulates the packet and sends back to the client over the yellow line. So it's pretty cool because when you install different solutions, tunneling solutions, you will have lots of interfaces. You need to care about the IP table rules, forwarding, routing, that kind of stuff. So that makes it more complex. But in this case, if you want to use different tunneling modules, you have only one interface. You need to set up only one IP table rule, and then you are good to go. It's pretty easy to develop I think it's pretty easy, or at least easier than it used to be to develop for this tool. This is the current module tree. This is how the frameworks look like from module perspective. There is the generic module, which has all the properties and methods that all the modules are sharing. It's object-oriented. So all which is below of the generic that inherits the generic methods and properties. There is a split here because there are stateful and stateless protocols which have to be handled a different way. For example, TCP is stateful, UDP, ICMP is stateless, and there is a split, and the stateful module has everything that the stateful modules like TCP have to have, like different functions and properties. What they are sharing, these modules are sharing, that's already implemented in the stateful, and the same is true for the stateless stuff. These three are called skeleton modules because they give a skeleton for all the other modules. Because it's object-oriented, it's pretty easy to develop for, because you don't need to write your own code. You just inherit all the stuff from the other modules, from the parent modules, and you can use it. Just an example, for example, the HTTP connect is using a proxy to make the tunnel. So you create a connection to the proxy, you send the HTTP connect method into the proxy, it builds up a stream with your XFLTReaT server, and from that point it's just the same like the TCP tunneling. So the TCP tunneling is just about 350 lines of code, and the HTTP connect is 150. So you can create your own module if it's like this in 150 or less lines. And again, a few examples. If you have a network where only web HTTP is allowed, port 80, then you just set up the tool on port 80 and you can do tunneling. If ICMP ping request is denied somehow, but the reply is allowed on your network, then you change the ICMP type 8 to 0, and you can do that. If there is some inspection tool or proxy on your network which allows only HTTP requests with a special header in it, you just copy the HTTP module, you add that one header into the source code, and you are good to go. It's pretty easy. If there is an HTTP proxy again, which allows only TLS version 1.2, you just copy the TLS module and set it strictly to TLS version 1.2, and you can use that for tunneling. If there is a need for a special authentication, in bigger companies, they usually use Kerberos over proxy. Then you just implement your Kerberos implementation in the right format. Because it's modular, you insert that authentication module into the framework, and you can use that kind of authentication in the HTTP requests. Of course, implementing Kerberos is not an easy thing. I know that, but there are already implementations on the internet which can be just a bit wrapped in a right way and used here. If you want to do out-of-band tunneling, for example, you have two mobile phones, you connect that mobile phone into your client laptop, for example, and to your server. You need to figure out how you do that, how you connect that. And you only need to implement how you receive and send text or SMS messages. And then you can route all your traffic over text and SMS. It's possible. That's just an example. So you need to think out of the box because there are lots of different ways, and the tunneling is just basically the same in every case. Of course, there are differences that you have to handle, but that's why it's a framework. It tries to handle everything. And I'm going to create a wiki on GitHub, but I'm working on this framework for the last 8 months. And I have other things to do as well, so I had no opportunity to finish this and just to start the wiki. So please read this source. There are some comments in it. There will be more comments. There will be a wiki. But if you want to develop for the tool, my best advice for you, just read the code sometimes. Yeah, and this is the demo part. Let me give you the demo. So can you see this well? Can you read this? Okay, great. If the demo guys are with us, then it will work, but okay. It's a bit lossy. I'm not sure why. Okay. So yesterday I was doing the demo in my room and I figured out it's not working, and I got crazy. I almost got insane because it was working in the UK when I left. I thought I just screwed something up, and it turns out that the hotel Wi-Fi is not working that good. It's not just slow, but they are redirecting all the DNS traffic probably to their own DNS server. I'm not sure that's the hotel or somebody else doing that. But it was really unpleasant because I spent like 3 hours to figure this out. It's pretty lossy now. Okay, I reconnected. Let's try now. So this is my Amazon server. I just set it up in Singapore yesterday. After I cloned the repository from GitHub, you need to do the configuration. I'm going to show you that in a bit. But on the server side, you just specify. You don't even have to specify anything because the default mode is server, but here you can see it's a server mode. I wanted to show you. So I just started it, and it's listening. It started a module it started a DNS module on UDP 53. There is an HTTP connect on 443, so you can connect to that port over HTTP proxy. There is ICMP, SOX proxy, TCP, UDP. These are the modules that I'm almost done with. And this is my other box where I have internet. That's great. And this is the configuration. After you downloaded the tool, you need to set up a few things, and really only a few things, depends on the module. But first of all, you need to set up the remote server IP. That's the IP where your XFLTReaT server is. Then you have some server-related configuration for the interface. You don't really have to touch this if you don't know what are these, or probably it won't conflict with other interfaces. You can set the MTU. There is authentication. The authentication is salted SHA-512 right now. Nothing special. Other authentication modules will be introduced, but right now I'm working on the transportation modules instead of authentication and encryption. And then you have all the modules. For example, there is the TCP generic. It's enabled here. It says yes, UDP generic is enabled, ICMP, SOX, HTTP connect, and DNS. So I just quit and type on XFLTReaT check. This is the check functionality. So it will send challenges to the server. When it's green, it works. When it's red, it's time it out, or it doesn't work for some reason. So as you can see that HTTP connect is not working right now. SOX proxy is not working because I set up the IP address to a non-existent proxy IP. That's not important for the demo. But the others, the green ones, are working. So you can do probably tunneling right now over that little stuff, over DNS, ICMP, TCP, and UDP. If you want to do tunneling itself, then you need to edit the configuration. You need to select what kind of tunneling you want to do. So let's start with ICMP. Hopefully that will work if it's not lossy. So everything is disabled except the ICMP. Let's do a check again. It still looks like it works. And yeah, let's start again. I set the variables to 2. It's a debug mode. And I start to listen on the S0. Everything that's going on there should be ICMP now. And let's open this page. In the background, you can see there is only ICMPs going on, so nothing TCP. At least it can't be seen. And if I download something, Let's see the speed. It depends on the network. Sometimes when the network is lossy, then the connection it just drops. But right now, it's downloading. Yeah, it's like 5 megabytes per second over ICMP. When you are done with ICMP, you go back to the configuration. You turn off ICMP and let's try DNS. The DNS is a proof of concept state right now because I had no time to finish. And if I do variables 1, you will see. So it does lots of different things. It tries to map out first what kind of records I can use. I'm going to show you in a bit. And let's open the NCC web page. Hopefully that will work. It's a bit slow because it's DNS, but otherwise it should work. Let's start this again, just to show you it's working over DNS. By the way, the web page is loaded. Or it's loading. You can see it's NCC group, but it's obviously a bit slower. So you can see all of the pockets are DNS pockets. Nothing else is going on. So I changed it from ICMP to DNS. So it's a bit slower, but it still works. So what happened here is it tries to map out the network. It sends a probe packet to the server over the DNS. If it works, then it tries to map out which is the best encoding, then what is the maximum length for upstream. This is what happened here. We can use the A record with base 64, and that's the best encoding for the upstream. And the maximum length of the packet can be 254 bytes. Then it starts to map out the downstream. It found out that the new record can be used for this one. Then it tries to find out the best encoding, which is plain text in the downstream, and it maps out the best length, which is 229. Yeah, so it loaded. It's a bit slower, and I think now it's slower than it should be. But when you download stuff over DNS, it is doing, yeah, I think it's lossy. So it's maybe not the best demo now. I'm not sure this is working properly. And on the server side, you can see the packets are coming and going in and out. Let me stop this. So back to the presentation. So that was the demo. And a few technical details, because this is a more technical conference. I started to do TCP first, which was pretty easy. When you have a TCP connection, then you have a dedicated socket for that connection itself. You can create threads for each client. It's pretty easy to handle. Then I started to do the UDP, which introduced new challenges. Because it's stateless, you only have one socket for all the clients. You need to handle all the clients in one place. It's like the pocket selector that I explained to you. You need to select all the pockets to the right client to the other way. And you need to make sure that who is sending the packet is an authenticated client. Then the third module that I created was the ICMP, which is just like the UDP, it's stateless. But I had more problems with that because most of the networks are firewalled or NOTed. So you have a solution, you have a device or software which is doing the NOT for you. And when you do that, when you send a ping out to somewhere from your network, you send it out, then that's an ICMP type 8 request, and there will be a ICMP type 0 response to that. If you send a request, there will be one response usually. And in the ICMP header, you have the identifier and sequence number. The identifier usually is a random number, and the sequence number starts from 0. When you send your first request, there will be the identifier, which is a random number, like I said, and there will be the sequence number with 0. When there is an answer to that, it will be the same identifier and the same sequence number with 0. When you send the second ping, then you will get the same identifier, but the sequence number will be increased by 1, so that will be 1. So this is how it is tracked, and the NOT solutions and the firewalls are tracking in the same way. So if you send one request, then there will be one response to that only. So if you send 2 responses, the second one will be dropped. If there was no request, then everything will be dropped with that sequence number and then identifier. So when you do tunneling and you want to download stuff from the internet over this tunneling solution, probably you will have more downstream than upstream. So you need to generate your upstream, you need to send more requests than you use for downloading. So you need to track all these packets. Then the last module that I'm working on right now is the DNS module. This is the latest one. Unfortunately, not 100% ready. It will be released today as well, but in a different branch on GitHub. So you can use it if you like, but it can be buggy because it's really extensive stuff that I have to. So it's really complicated. The DNS itself is not complicated. The RFC is well written. It's easy to read. You can create your DNS server or relay in 1 or 2 days. It's pretty easy. But if you want to do something else than DNS, I mean, use DNS for tunneling, that's a bit harder. So right now, it's not 100% ready, but I tested with Bind version 9, and it works really good. It supports A or C name, null and private records, and there is the auto-tune functionality, which I showed you during the demo. It tries to map out the best upstream and downstream variables, and yeah, you can build up your tunnel over that. It's just like ICMP. So when there is a request, there can be only one answer to that. So you have to make sure that you send more requests than as many answers you need. Null and private is usually used for tunneling because they have a really huge payload, which is 16 space for payload, which is 16 kilobytes. But to be honest, you can't really use that because the RFC says that the DNS should work on both UDP and TCP. If the packet is just about 512 bytes or less, then you should use UDP. But it's not, it's a recommendation. It's not something that is specified exactly. And if it's more than 512, then you should use TCP. Obviously, when you are on a network, which is everything is filtered except DNS, then UDP will be used only. You can't make connections over TCP on the port 53, so you need to stick to the UDP. But when you do tunneling over UDP, I mean DNS, then there will be the IP header, there will be the UDP header in the packet, the DNS header, and when you send a request about the domain name, that will be included in the response. So it depends on your question, your request, the answer will be partly the same. And if you had a huge request, you have less space for the response. So you need to balance with that. Fragmentation needs to be improved, introduced in the framework. I started to do that, but it was a bit more complex than I thought, so I had to give up for now. And this is one of the reasons why it's Linux only at the moment, because I need to do the fragmentation, because it is solved. It's working really well, but on Linux only because it's hacky. I did MTU manipulation and MSS manipulation, which is the maximum segment size. I downgraded it like 100 bytes. It's dynamic. It depends on the size of the UDP packet, but it's a hacky solution. I want to do my own fragmentation, and then it will be released on different operating systems as well. And one more thing why it's more complex than the other modules, because the RFC gives you recommendation about the DNS, so all the DNS servers implementation differs a bit. So, for example, the domain names based on the RFC should be only letters, numbers, and hyphen. So you can't really put anything else into the domain names. And that should be case insensitive. But for example, bind can handle not just ASCII characters, it can handle almost all characters in the domain name, and it's case sensitive. So you can do different encodings with those as well. So you need to handle these little bits and bobs, which doesn't make life easier. The tool can be used on both sides, offensive purposes and defensive purposes. I start with the offense because that's my favorite part, and I do that as a daily job. With the tool, you can bypass basic and other basic obstacles. If you have a port or protocol unfiltered, then you just set the tool on that port or protocol and you can do tunneling. If you need a special header or special authentication, you just modify the code or introduce that authentication module. You don't have to do anything about the tunneling itself. If you do offensive security, then you can exfiltrate data with this tool. This is not strictly an exfiltration tool. It's more about tunneling. So if you want to exfiltrate slowly, probably this is not the tool for you. But if you want to do tunneling and you don't care about the speed, you don't care about the volume of the packets, then you can use this for exfiltration. And I think the best thing about this, you can get unfiltered internet access on restricted networks. So that's why I started to work on this. On the defense side, on the other side, you can use this tool to improve your network, to figure out the weaknesses of your network. So you should set up the XFLTReaT server outside of your company, for example, on an Amazon instance, then configure it properly based on your network configuration, and try to make a connection and exfiltrate data. So that's my best hint for you if you are on the defense side. Try to exfiltrate data, because you need to be the first one who does that in your company. Otherwise, you already had a breach. And you can test your SOC team with this tool. If they can catch the traffic, then I guess they are really good at what they are doing. If you have a captive network in your company, for example, a guest network, captive portal in your company, for example, a guest network, then you should follow my recommendation about this. You should drop all the inter-client connection, inter-client communication. You should drop all the packets except those that are addressing the captive portal, and you should rewrite all the DNS queries responses to have the captive portal's IP, and that way the client will be redirected to the captive portal. After the authentication, you can drop these rules. You can give unfiltered internet access to the client, but otherwise you should do these, because that way the attacker, the client, can't do tunneling, not even DNS tunneling, because all the responses are rewritten. Unfortunately, there is no 100% solution, no 100% secure in this world. I can give you some mitigation about DNS tunneling in your company, and this is another one, but it won't be fully secure. I think what you should do in your company, if you have a network, then you should try to modify it a bit based on this. If you are planning to build up a new network, then you should follow these recommendations. So first of all, do not route anything to the internet. Your internet network should be internal only. You should set up a set of proxies which have unfiltered internet access, and all the clients should be enforced, not just the clients, the servers itself. Servers, workstations, clients, guests, everything should be enforced to use HTTP proxies. And on the HTTP proxy, you should do whitelisting on port 80 and 443. The employees usually don't need anything else. You can do blacklisting as well, but that doesn't help on exfiltration or XFLTReaT. When you have your proxies, they should resolve all the DNS queries, not you. So you should have just internal DNS servers which are replying to internal domain names, no external. The client doesn't need to resolve external host names they shouldn't resolve external host names. The HTTP proxies have a support for that. So if you send a request with a host name, they can resolve it and give you back the result. So you don't need to care about that. Of course, there will be an exception list. For example, your Exchange server and different servers that need unfiltered internet access. But 99% of your other computers in your company, the servers and clients included, should not get unfiltered internet access. They should use the proxy. If you have an inventory, that's really good. You should keep up with that. If you don't, you start with that right now. So that's the basic of the IT security, I guess, to build up an inventory of your company. In the inventory, you should have the IP addresses, the location of the boxes, the owner of the boxes, the purpose why it's there, and probably a contact to the owner. If there is something suspicious or malicious is going on your network, you just call the guy to unplug that box from the network, and you are safer than you were, and you have some time to investigate that accident if there was an accident. After you have your inventory, you should do baselining. You can use NetFlow or Bro for this reason. With this, you create a statistical map of your network. You need to identify the top talkers, the IP addresses that are communicating with each other, the frequency of the communication, the volume of the communication, the protocol. So you create this statistical map, and if you are confident with it, about it, you can put it in alert mode. And if there is an alert, it may be a false positive, and you just add it to the statistical map, and that's fine. But if it's not a false positive, then you have a breach, you have an accident or something on your network that you should investigate. And that way you can know about this in minutes or hours. Yeah. So that's probably the most important question of me today. Do you want this tool to be released? Please raise your hands if you do. Okay.
Nice.
Thanks. Yeah, some people raise both hands. Yeah, it will be released on GitHub. You can open the web page right now. It gives you some information. If you forget the second URL, it's already on the first URL, which is XFLTReaT info. It's pretty easy to remember. Right now it's not on GitHub. I need half an hour to move it there, but it will be there in an hour. So please be patient. In the next months, I will work on the DNS module, of course. I will try to do the fragmentation and the multi-operating system support. Probably if you test it and you create issues on the GitHub, I will do those as well. So I will be busy. I don't have a timeline for this. And I try to do more commenting in the code. There will be more authentication modules, and there is no encryption at the moment. That is one of the last things that I want to do, because it's more about tunneling and not about cryptography. But yeah, I will do those in a while. So thank you for your attention. If you have any questions, we have 11 minutes. Or if you don't have any questions right now, you can find me outside after the presentation, and I'm happy to have a chat about the tool, about myself, and CC if you have any questions about this, or just you want to talk, then I'm free. Any
Before
questions?
we start the question, can we have another round show of hands? Who wants this released? Yeah, excellent, thank you.
Thank you.
Any questions from the floor? Yes, okay, so we'll take this gentleman at the back, the mic is here, and we'll go.
I don't actually have a question. I just wanted to say that was an excellent talk.
Oh, so, thank you.
Thank you.
Thank you very much. I hope you will like the tool as well, not just my talk, because that's a bit more important for me.
Just a bit.
Yeah.
Yes, I guess I would really like to do.
Thanks.
And the talk was good. I wanted to know if how do you intercept on ICMP? How do you intercept or how do you receive the ICMP stuff? I guess you have to run it in kernel mode or intercept all the traffic to the IP address?
No. So it's pretty easy actually. So I didn't mention that for running the tool you need root privileges because you need to set up the interface and only root can do that. And in the same reason you can do row sockets on Linux and I think on Windows as well, there is a way. And if you have row sockets on ICMP, you will get all the ICMP packets. So including everything. And there is a setting in all operating system. If you set, then the kernel will ignore all the ICMP packets, so it won't answer to ping because that's a kernel functionality. If there is an ICMP request, the kernel will answer right away, and after you will get the packets. But if you turn this off, then the kernel won't answer, so there will be no interaction with the kernel, and you can handle your stuff like it's a TCP or UDP socket.
So it would also be possible, or not that hard, to get it run without root privileges, to just limit on Linux you can give a process some certain privileges and not complete root access. So you could easily limit it to just open the interface and these raw sockets and so on, and just drop root.
Yeah. That's actually, it's planned in my head that after you have everything with root privileges, you just drop the privileges and you will get nobody or some other user and it will run, yeah.
Okay, then thanks again.
Thank you.
Is there a specific reason you used A records in DNS tunneling, not quadruple A or TXT records?
So I'm not sure I was pretty clear about that. When you send a request with DNS, you need to specify the domain name and the record what you want to request. When you upload, that's like a A or C name, and that's the only thing that you can do. So when the upstream is not really A or C name, it doesn't matter. What matters is that it should arrive to the server. So I don't use A itself for downstream. I use C name, none on private right now. The only reason because these what I use, because these are easy to use and these are essential. So null and private is really easy to use. And CNAME is a must-have because that's the basic everywhere, and it can't be filtered because if you filter CNAME, then half of the internet will broke in your network.
It just seemed that you would have more downstream capacity with like IPv6 records. I don't know. What do you use for downstream for responses?
Null, private, and CNAME. So you can't really use A records because that's only 4 bytes. If IPv6, it's 16 bytes, I think, or 8. It's 16, I guess. So that's just not enough. What you can use again text, TXT. You can use CNAME. Null private, and there is a lots of others which will be implemented, and it's pretty easy. It's like half an hour work to implement more records for me because I need to know how to create those records, how to read data from those records, but it's really easy. I just read about some other records in the last month that are used in DNSSEC and for HTTPS verification, and you can transmit data over those. And you can't really filter those because that will be needed for verification and DNSSEC, right? So yeah, I will use more modules. I hope I answered your question.
Thank you.
Thanks.
Hello.
Hi.
Hi. Have you had any issues reassembling the data, especially with those stateless protocols?
Actually, I had issues with everything. That's the way how you develop. when I did the fragmentation, I had lots of issues and I had no time to figure it out why. I think the DNS is pretty lossy because first of all it's UDP and second it's DNS. So how the usual tools on Linux, for example, works, the host or dig, it's like it sends one request. If there is no answer, it sends another request in 2 seconds and the third request. And if there is no answer for the third, then it gives you no results. But usually it gets the result for the first time. But there is this fail-safe solution for that. So it's pretty hard to do anything over DNS because it's lossy. And if you do fragmentation, you fragment one packet to 10 and you lost only one, then you lost all of them actually because, you can't use the rest 9 packets to assemble, which was 10 packets before. So yeah, I had problems with that, but basically, everything that the kernel does for you, it's really great. So you don't really have to care about IP level, usually, only if you do fragmentation.
Thank you.
Thanks.
Any other questions from the floor? Probably off stage for the others. Well, thank you very much, Balazs.
Thank you.
Thank you. That was a great talk.